All right, hello everyone, and welcome to today's lesson, which is on factoring special cases. And when I say factoring special cases, I am talking about the difference of squares, which is going to be, you guys are used to factoring trinomials. This will be a binomial. So we can only factor certain binomials with this method, and we'll talk about kind of what this looks like and how to factor it. Okay, but first, we are going to introduce this story kind of in a unique way. We're going to introduce it with a love story. Okay, so I don't think I have the love story on my slides actually, so you're just going to have to follow along. I did not make this myself. I actually got it from a different teacher at a conference that I went to, and I thought it was kind of funny, so I thought I will share that story with you now. All right, so we're going to call this the story about different squares, and it takes place in Squaresville, USA. So once upon a time, a long time ago, there was a place called Squaresville. On every February 14th, which is Valentine's Day, a special bus came down the hill looking for special numbers to take to Squaresville. All of the numbers wanted to come, but the bus driver was only allowed to bring perfect squares. So let's kind of review what a perfect square is. They are numbers that if you multiplied another number by itself, you would get this answer. So for example, 2 squared, or 2 times 2 is 4. So 4 is a perfect square. If I did 3 times 3, 9, also a perfect square. You could do maybe 10 times 10, so 100. You could also do variables. So we're talking about numbers, but it could be variables too. So for example, x times x. X squared is a perfect square. Or maybe it's, let's see, 5x times 5x. That would be 25x squared. So it could be a combination of numbers and letters as well. But all of these that we just listed are examples of perfect squares. So they would be people that the bus driver would allow on the bus. I'm going to continue with my story now. Once the bus was filled, off it drove through the special gates into the land of Squaresville. The first stop the bus always made was at Squaresville High School. Here was the perfect place for all the squares to meet and make friends. And as it all happens in all high schools, as soon as the squares got together, love blossomed, and A squared met B squared, and it was love at first sight. They were inseparable. They went to all the dances together, helped each other with their math homework, of course, and they got along great. On their book covers or on their notes, you would always find A squared plus B squared. And they put a little heart around it. But then one day it finally happened. They were having their differences. And if you remember, differences means subtraction. So no longer were they getting along. So they decided to break up. As they were sorting through their problems, they decided when we break up this, we're going to break it up into 2 binomials. They're going to remember 2 things. They're going to remember the good times, so A plus B, and they're also going to remember the bad times, A minus B. Remember good times, remember bad times. The good times are why they fell in love, and the bad times are why they broke up. And this is how we factor a perfect square. So 2 things have to occur. We have to have a subtraction sign, has to, and they both have to be perfect squares. If that's the case, we can factor it. And what you do is you take the square root of the first term. So the square root of A squared is just 1A. And you take the square root of the second term, which is just 1B, and you put 1 plus and 1 minus. Okay, so let's see what this looks like kind of in action here. All right, so first double check. Those 2 things that we talked about had to occur. It had to be perfect squares and it had to be differences. We only split them up if they are arguing or fighting. Then we're going to split them up. If there's a plus there, that means they're still in love and we're not going to separate them. All right, so if you look at the first one, perfect square, yes. Perfect square, yes. Are they having their differences? No. So can we factor this one? No, we cannot. All right, the second one, we have perfect square, yes. Perfect square, yes. Are they having their differences? Yes. So we can factor this. Let's go ahead and factor it. So we're going to break it up into two binomials. You take the square root of the first term. So the square root of 4a squared is 2a. 2a times 2a gives you 4a squared. We put that first term in each of the parentheses for the first number. All right, take the square root of the second term. Square root of 25 is 5. We put that for the second number in each of the parentheses. Then they have to remember the good times and the bad times. And that is your answer. You could check it to see if it works. So I'll check one, but I won't check all of them. So 2a times 2a is 4a squared. That's good because I have a 4a squared up here. 2a times negative 5 would give us negative 10a. 2a times positive 5 would give us positive 10a, and 5 times negative 5 would give us negative 25. If I combined my like terms, my negative 10a and positive 10a, I would end up with 0 a's, and that's where I would get what I started with, which is 4a squared minus 25. Again, that was just checking. You don't have to do that. I just wanted to make sure you saw the reason why this is the answer. Okay, so let's do a few more. Is there a perfect square? Yes. Perfect square? No. So can I factor this one? No. All right, next one. Perfect square? Yes. Perfect square? Yes. Are they having their differences? Yes. Let's split them up. So take the square root of the first one, which is just 1m. Take the square root of the second one, which is 3. Remember the good times, remember the bad times. That would be our answer, m plus 3 and m minus 3. All right, let's try a few more. Okay, look at your first term. Is it a perfect square? It is not. 8 is not a perfect square. So can I factor this one? No. All right, second one, 25a squared. Is it a perfect square? Yes, it is. 64, perfect square. Are they having their differences? Yes. Let's split them up. All right, so we're going to remember the good times and the bad times. So if you want to go ahead and put 1 plus 1 minus, go ahead. Square root the first number. Square root of 25 is 5. Oops. So I have the square root of a squared is a, so there should be a 5a in the front of both parentheses. The square root of 64 is 8, so it should be a plus 8 and a minus 8, and that should be your final answer. 5a plus 8, 5a minus 8. All right, next one, perfect square? Yes. Perfect square? Yes. Are they having their differences? No. Can you factor this one? No. All right, next one, perfect square? Yes. Perfect square? Yes. Differences? Yes. We can split this couple up. Square root, both terms. The square root of 9m squared is 3m. That goes in the first parenthesis of each one. The square root of 1 is 1. Remember the good times, remember the bad times. And that would be your answer. All right, last two problems here. All right, perfect square? No, but if you think about it, we have learned many ways of factoring, and I didn't talk about this, but I was kind of wondering if people would get it. Think about your checklist. Our first thing that we always look for whenever we are asked to factor is to look for a GCF. So this one is a tricky one because it has a GCF. of 5. And so when I take out or divide them each by 5, I end up with a perfect square, and they are having their differences. So I can go further now. So I'm going to keep my GCF, and then I'm going to split that into 2 binomials. Square root a squared, which is just a, square root 100, which is 10. Remember the good times, remember the bad times. And that would be our answer. All right, this next one, again, you would look perfect square and you would say no, but don't forget, check for GCF. This one has a GCF of 3. Let's divide them both by 3 to get w squared plus 100. All right, let's see if we can go further, because we did factor it a little bit at least. Let's see if we can go even further. We have a perfect square. We have a perfect square. Are they having their differences? No. So I can't go further, but it was factored some. So that would be our answer there of 3, and then in parentheses, w squared plus 100. All right, tonight's homework is just going to be a mixed review of all of the factoring that you guys have already learned. If you have any questions, don't hesitate to reach out. All right, see you soon. Bye.